Hello everyone. So today we are going to discuss another problem on Hamiltonian and Eulerian graphs. So let's begin. State with justification whether the following graphs are Hamiltonian or not. Are they Eulerian? Justify your answer. So we are given figure A and figure B. So figure A is this and figure B is this. So let's find out whether they are Hamiltonian or not. So if some of you guys don't know what is Eulerian graph, so a graph in which like we can traverse all the edges exactly once, and all the edges can be traversed exactly once, and we are able to cover all the edges of the graph, then this is Eulerian graph, right? And if suppose we have here, like in this graph is a Eulerian graph because we can traverse it, but suppose we have here this particular edge as well, and suppose we have these two edges as well, right? So then this is no longer a Eulerian graph, because no matter how you try, like from this way, whatever way you can try, so it will not work out to be a Eulerian graph. You will have to cross over between edge twice in order to cover all the edges. So a rule which you can keep in mind is that if any vertex in a graph has odd degree means number of edges incident on that vertices is odd, then it cannot be Eulerian or Euler graph. So it will not be in that case. So it is a standard result we can follow. So if we talk about Hamiltonian, so Hamiltonian means a graph which has a Hamiltonian circuit, right? So we are not talking about means there can be a Hamiltonian path in a graph, but it does not necessarily mean that it is a Hamiltonian graph, because for a Hamiltonian graph there has to be a complete circuit, Hamiltonian circuit, so that we can call it as Hamiltonian graph. So a Hamiltonian circuit is a circuit in which all the vertices of the graphs are visited at least once, or at most once, right? It's not at least, at most once. So if we take another example, like here, so if we start here and then come here, then here, and then down here, right? So let me use another pencil. So if we start here, then come here, then here, then here, and then here. So this is not a Hamiltonian graph because we have not completed a circuit. It is a Hamiltonian path, but it is not a Hamiltonian graph. But if we have another vertex here, and then we extend this graph here and then here, there is also edges here as well, right? So there were edges, and we can then say that the starting and the ending vertex is this, and we visited all other vertices exactly once in the graph. So we can say that it is a Hamiltonian circuit. So if we come back to the problem, then in this graph there is a Hamiltonian circuit. If we start from the top right and then go here, down, come back here, and then up, so we reached the final vertex from where we started. So it is a Hamiltonian circuit. Now if we come to the later graph, this one, and suppose we start from here, right? So we come down here, then down here, and similarly we are able to complete, or what we can do is, we have reached the vertex twice, so we can do it another way. So then we will exit here and then we can complete it. But remember that we started here, right? We started here, but we are not able to reach back there. So this is not a Hamiltonian graph. It just has a Hamiltonian path, but it does not have a Hamiltonian circuit. So this is not a Hamiltonian graph. Now talking about Euler graph. So in this graph, you may see that this is a odd degree vertex. So as we discussed previous in the video, an odd degree vertex indicates that this is not a Euler graph. Similarly here, if we check, we again have a odd degree vertex. So this also does not have Euler graph in it. I hope you were able to understand. Thank you.